Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Ayun Hisna binti Azizan. My metric number is S47587. I was supervised by Associate Professor Dr. Faizal Tushima Mehamud. My final year project is about synthesis and characterization of bis-2-ethyl acyl phthalate imprinted polymers via precipitation polymerization with metacrylic acid MAA as the functional monomer. Molecularly imprinted polymer can be obtained when the functional monomer bind to binding site of a template by self-assembly. When polymerization occurs, the cross-linker will form polymer matrix. After that, the template will be removed and form cavity. This structure is called imprinted material. In this study, bis-2-ethyl acyl phthalate was used as a template, metacrylic acid MAA as the functional monomer, DVB80 or divinylbenzene 80% as a cross-linker, and azo-bis-isobutyron nitrile as an initiator. So, objective for the study is first to synthesize the DEHP-IP and NIP via precipitation polymerization with MAA as the functional monomer, and second to characterize the synthesis of DEHP-IP and NIP using SEM and BET. For problem statement, DEHP has been widely used as plasticizer, but it is toxic to the nature and can cause cancer to human. So, in this study, molecularly imprinting technique was used to produce an absorbent material called DEHP-IP. From previous studies, Xia et al. Saying that the study of MIP for DEHP using metacrylic acid as functional monomer and N-methylene bis-acrylamide as crosslinker and ammonium persulfate as initiator, and this polymer was synthesized by suspension polymerization. So, in the absorption study, it shows that when amount of DEHP increase, the binding of DEHP towards the polymer will also increase. To synthesize DEHP-IP and NIP, first, MAA and DVB80 was purified. The chemical will be mixed into a Nalgene bottle labeled DEHP-IP and NIP. So the mole ratio that have been used for template to monomer to crosslinker were 1 to 4 to 20, and the scale that have been used is 5 gram. And the mole ratio for solvent used, which is acetonitrile to toluene, is 1 to 3. Template will be absent in NIP. The Nalgene bottles labeled DEHP-IP and NIP was put into the ice bath, and the solution was purged with nitrogen gas to remove the oxygen. So both Nalgene bottles was left in a roller bed for 48 hours at a constant temperature, which is 60 degrees Celsius. Then hydroquinone will be added to stop the polymerization. The product was filtered and dried in the oven. Then the product was weighed and characterized using SEM and BET. Synthesis of DEHP-IP and NIP produce white powder with percentage yield 64% and 67% respectively. This is due to some of the product was stuck at the thimble during filtration, also caused the decrease in the amount of product obtained after synthesis process. So the amount of the product is less from the scale, shows that the template was successfully removed from the polymer. So these are the image of DEHP-IP and NIP under scanning electron microscope SEM for magnification 4500 and 2500. The polymers are obtained in beads-like particle because it was synthesized using precipitation polymerization. DEHP-IP particles form in range 5 to 10 micrometer, while NIP was below than 5 micrometer. So from the BET result obtained, the surface area and the total pore volume of DEHP-IP is higher than NIP. This indicates that DEHP-IP has vacancy size and porosity surface for absorption of DEHP. BET data can confirm that DEHP-IP is rougher compared to NIP, which indicate that DEHP-IP have higher porosity than NIP. As the conclusion, the synthesis of DEHP-IP and NIP give percentage yield for DEHP-IP equal to 64% and NIP is 67%. So morphology of DEHP-IP and NIP shows that DEHP-IP give a rougher surface compared to NIP. While for Brunner and Teller, The surface area and pore volume of DEHPIP is larger than NIP. That indicates DEHPIP have higher porosity than NIP. Thank you.